past makes us curious. We wonder about life then. What was it like? Were people like us? Were they curious too, and did they wonder about the world around them? We're interested in the people of the past because they are our ancestors, and we sense that they must have been like us. Humans use trial and error in order to understand. Humans experiment. In Land of Legends in Lejre, we do exactly the same thing. We examine and try to understand the people of the past and the conditions in which they lived. The people of the past were always changing the world about them by taking up new opportunities and making technological progress. And we are constantly changing the way we understand their world. We are continually rediscovering the past in our own ways, for we can never arrive at the absolute truth about the past. For most of the 100,000 years in which we humans have been producing tools, the most important raw material was flint. So research into flint implements and experiments carried out into their use and manufacture are the key to help us to understand many aspects of the way people lived in the past. Flint knapping is a craft that became extinct and now has to be rediscovered. In Land of Legends in Lejre, many researchers from home and abroad have taken part in these experiments. One American researcher has devoted most of his life to trying to become just as good as the craftsmen of ancient times, and one thing he does is to reproduce the beautiful flint daggers familiar from the end of the Stone Age and the beginning of the Bronze Age.
It wasn't until I came over to Denmark and looked at the originals rather than just pictures in the book that I turned them over and see three-dimensionally just how complicated they were and beautiful. And the more I did, the more complicated they seemed to be. So 25 years later, I occasionally come close, but I don't know that I'm even good enough to fit into Neolithic society if I were there.
Flint knapping is a very complicated craft. The large flint block, the core, is attacked systematically. Every strike is carefully planned and thought through, like a chess player planning his next move. You can hit the block directly with another, harder stone, or hit it indirectly. Then the strike is transmitted through a short point made of antler. We should admire the craftsmen of ancient times. It takes years of practice for a modern craftsman before he can knap flint as well as they did. If you want to investigate methods of craftsmanship, for example, you need to be good enough to know what was possible at the time. A few of our modern researchers and flint knappers have become specialists and experts, just like the flint masters of ancient times.
This large blade core is now ready to give blades. Let's look at it. It has a large platform. It's organized with two front crests and a back crest.
The flint knapping session is part of the series of experiments that will show how blades up to 30 to 40 centimeters long could be produced in the Neolithic age. Just like the flint daggers, they are among the very finest examples of flint craftsmanship.
So the documentation consists in taking notes and describing these different series, using a datasheet system for each of one, and also using macro photos.
A researcher has to be good enough at his craft if he's to ask the right questions about other ways the blades could have been made. Might there have been a Stone Age machine, for example, capable of transferring and increasing the force with which the central strike point in the core was hit? There's no reason to believe that people living in the Stone Age did not have experience with laws of physics such as the transmission of force. We observe the results of fantastic craftsmanship, the working processes of which we've only gradually begun to rediscover.
Oh, this is a good blade.
Working with experimental tools creates signs of usage called wear traces. These can be compared with the wear traces on original ancient flint tools. This allows us to confirm or dispel the likelihood of a usage proposed for a particular ancient tool. The experiment being carried out here is aimed at finding an explanation for a special type of small flint scrapers. They've been found in large quantities and have characteristic small-toothed long sides. What was this tool used for? In order to find the answer, copies of this flint tool have been reproduced, and the copies are now being used in the processing of different plants. By scraping the stem of the stinging nettle, it's possible to loosen fibre, which can later be used for making cloth.
The most exciting part is taking these tools back to the laboratory and looking down the edges onto the surface to see that actually they are a promising match for the archaeological pieces that we find. Whatever these tools are, they're used for a very long time, and a lot of people in a wide area of Europe are using them.
Dolmens and passage graves were built 5,500 years ago by Denmark's earliest agricultural population. A question which naturally arises is how on earth they could have managed to move such large stones. When we look more closely at both dolmens and passage graves, we see that they are covered by huge capstones which form the ceiling of the grave chamber. Pulling large stones over long distances is actually not that hard. All you need is enough manpower. It's much more difficult to understand how Stone Age people were able to position these heavy stones, weighing up to as much as 20 tons, with such precision. Levers were used for the handling of a megalith, which would gradually be levered higher and higher, while wedges were constantly placed under it. The last part is the most difficult. Here it's possible to use an A-trestle, which is an ingenious method of utilizing the principle of leverage. A rope is attached to the top of the stone, and this rope is connected to the crossbeam of the A-trestle. At the top of the trestle is another rope, which is then pulled, thereby creating a force at the top of the A-trestle, which makes it easier to raise the megalith to an upright position.
Free pull! Yeah! Free pull! Yeah, very fine. Hold it there. A little more. 1, 2, free pull! Yeah, that's it. 2, 3.
The large capstone of the dolmen weighs approximately 9 tons. The Danish king Frederick VII was the first to propose a method where the stone could be drawn up to the top of the mound via an earthen slope.
Bare stille og roligt. 2, 3, træk! But I can see we need the next 10 already. Træk! We need 5 more people at the long ropes. Træk!
We do not have sledges preserved in archaeological finds, but if we travel around the world and observe how primitive peoples move large stones, we know that they use sledges. It took 80 people to pull this large 9-ton capstone all the way up the hill, up the slope, and then up onto the top of the grave chamber. This tells us that the people who were found in the grave chambers were able to gather many others to help them build a monument for themselves or for their kin. And suddenly such a building project is no longer just a monument for the dead, but also for the event that it must have been to build a burial mound. You can imagine that word was spread about the large dolmen in Lejre for a long time after it had been built. It would have been an event where a feast was held as a celebration of the raising of the stones and the building of a monument for the lineage of those who stood for its creation. This is what can be told from the accounts we have of primitive peoples, especially in Indonesia, where graves quite similar to our local Stone Age graves were built all the way up to the First World War.
Hold! Ja, men den holder også.
Experiment is a word that makes us think of laboratories and natural science subjects such as physics and chemistry. Many archaeological experiments are actually conducted in close cooperation with other areas of science. One example is a series of experiments done on the construction of the large mounds from the Bronze Age. Some of the mounds were built in such a way that the dead, who were buried more than 3,000 years ago, were preserved with their clothing and burial gifts. The Ecktved is one such case, as are other burial mound peoples such as the find from Borum Eshoy. They were preserved due to the oxygen-depleted environment at the centre of the mound. By building a number of small mounds in Lejre, it was discovered that during the construction process, large amounts of water were probably added to the innermost regions once the sods had been stacked closely around the coffin. This could have been one of many rituals performed while the mound was being built. A total of 4 different models of Bronze Age mounds were built in Lejre to a scale of 1 to 4 and 1 to 5. Developments in the soil environment of the mound were measured, and to see how this affected preservation, sides of pork and entire piglets were buried in oak coffins in the mounds.
Så man er klar. Lejre et fri.
Vi starter med et stykke skind. Det ser hovedet, så en rød.
We are starting with a piece of leather placed at the head with a bit of yarrow beside it. Then we have a piece of bronze on the piglet, along with a piece of amber, which has been broken in half. Finally, we lay a piece of woolen cloth like that of the Ecktved girl.
Så må den hvile i fred der.
3 years later, the mounds were excavated. The side of pork was so well preserved that at least by scientific standards it was still edible.
Men du kan stikke næsen ned i den uden at...
However, the piglets were more decomposed. The experiments on the construction of the mounds were the beginning of a major research project including many other methods. One result was the excavation of Skelhøy, a large protected barrow near Kongeåen. This burial mound was probably built by hundreds of people organised into building teams. Behind the construction of the mound lies a definite architectural idea, and not least, great organisational and technical knowledge. The experiments at Lejre have taught us more about the mound building practices of the Bronze Age people. We've learnt that the actual grave was not the only important thing, but also, to a great extent, the way in which the mound was constructed. In Lejre, the Iron Age village, we've shown how we believe houses looked and were laid out about 2,000 years ago. The organisation of the village, the individual buildings and the details of their construction are a three-dimensional model of our picture of the past. In archaeological digs, traces are found of the posts of the houses by way of filled holes in the ground. And from these traces, we've attempted to build a house as a dwelling for humans and animals. In 1967, an experiment was conducted in Lejre to see whether the way in which we built houses in Lejre was at all comparable to that of the original houses. On the morning of the 9th of August, one of the Iron Age houses was set alight. The blaze spread quickly from a large fire in the hearth to a wooden drying shelf and thence to the roof.
Husets mønning synker ganske langsomt.
The peak of the roof is sinking, slowly down. Now the whole eastern end of the house is crashing down. And the hole in the eastern end of the house is blocked. The rafters are sticking out, almost like the ribs of a whale. They're sticking out more and more, and not yet burnt up. It's very interesting to see this. After 15 minutes, the whole roof caves in. 20 minutes later, the entire supporting wooden structure collapses. And after approximately an hour, the house is just a smoking ruin. The house was burnt down to create a snapshot of a situation also familiar in ancient times. In 1992, 25 years after the burning of the house, the site of the fire was excavated. Burning a reconstructed house showed us what happened during the fire itself. By excavating the site afterwards, it was possible to make a direct comparison with archaeological sites of burnt houses. But what was life like in houses like these? For 3 winters, a group of archaeology students spent 2 weeks at a time in the houses in the village of Lejre. The group gathered information on temperature, draft, smoke, and other measurable conditions. From excavations, we know that the eastern end of the house was arranged as a stable. But why did they choose to have humans and animals living under the same roof? Our housing experiment showed that it didn't make a difference as far as the heating of the house was concerned. The experiment shook our often idyllic picture of a past with its cosy houses. Our measurements also showed that the indoor climate of the houses was very poor. A number of hazardous substances in the smoke from the fireplace meant that in some places there was air pollution comparable to heavy rush hour traffic. Which sword is best? Back in the Iron Age, weapons were also constantly being improved with the help of new technological discoveries. The raw material bog iron ore was available from many Danish bogs. When bog iron ore is dug up, it's very hard, and initially it's roasted over a fire. After this, it's smelted in a furnace.
I jernudvindingsovnen brænder man med trækul.
In the oven for the extraction of iron, charcoal is used, and it's the flue gases from the charcoal that react with the ore in such a way that iron is formed. In contrast to modern blast furnace methods, iron is formed in these ovens as solid iron. The iron does not melt at any point in the process. What you can see flowing out of the oven is molten slag. Slag melts at approximately 1200 degrees Celsius, and when you blow with a pair of bellows, you can reach a temperature of approximately 1400 degrees Celsius in the oven, which gives the slag a heat reserve which allows it to flow away from the oven. The iron itself remains in the oven as a solid mass, called the bloom. Contrary to what many people believe, bog iron ore is quite a good quality of ore, with the iron content in the best types to be somewhere between 50 and 60% pure iron.
I de gode myremalme et sted mellem 50 og 60%.
In Lejre, we've held seminars on the extraction of iron where researchers and experts from many countries have shared their experience and knowledge. There are many processes before you have a finished product. After extraction, the iron bloom must be cleansed and then finally forged. All processes leave traces and waste products which show up in archaeological finds. The waste products from each process are registered. This gives us a better background upon which to suggest where and how the same activities were undertaken in ancient settlements. In Denmark, the local bog iron ore was used for iron implements. Many other goods, for example glass and bronze, were traded for with other Germanic tribes or with the Romans. Experiments have given us a way of determining where implements of iron came from. Their origins are revealed by the small residue of slag encrusted in the iron, which can tell us where the iron was originally extracted. This also tells us about ancient trading routes.
Second finishing operation with the pencil. Yes.
Shards from broken clay pots are the most common finds at archaeological excavations. Vessels, cups, serving dishes and other containers of clay have been important to human beings in all times. Many experiments are done to see how we can extract more knowledge from the many broken and crushed shards.
Here we have the following archaeological problem. We found a lot of ceramics from the 4th millennium BC in Jordan, and they all present very different surface features. So the experiment here is the following. We're going to try to find out exactly according to which finishing techniques these different surface features have been made, and for this we're going to have an experimental process where only one parameter will change at a time. This parameter can be the type of clay. We change the dimension of the inclusions. It can be the amount of water. It can be the tool itself, and it can be also the state of dryness of the clay when it is worked on.
Whether the vessel was fired in an open fire or in an oven may also make a difference, so we test both methods. While the clay objects are being fired, their temperature is measured carefully to allow us to describe the importance of the firing process for the vessel's final appearance.
We reach almost 1,000.
Researchers know how the finished experimental clay objects have been produced, how they've been polished, and how they were fired.
This one? Is temper in this one?
Fine temper.
Their appearance can then be compared with the appearance of shards from archaeological finds.
We have to go back to the archaeological pieces and check out that.
It's also possible to suggest how the original vessel was made, and thereby reveal the methods used by the potter. Craftsmen of today are akin to those of ancient times. A skilled craftsman knows what works and what does not. This is knowledge which has been stored through many years of experience in the craftsman himself, and which cannot always be put into words. This is knowledge of the hand, or unspoken knowledge. Many of the best archaeological experiments are therefore conducted by a highly skilled craftsman and an archaeologist working together. From prehistoric Denmark, we have a unique collection of Iron Age and Bronze Age clothing. In Lejre, we've reconstructed many of these known examples of clothing over the years. Some of the garments were made using a drop spindle and on an upright loom. From archaeological finds, we have examples of warp weights. The dress worn by the Ekved girl is one of the oldest known to us. Maybe it was worn in connection with ritual dance. Here are other Bronze Age costumes from oak coffins. Jaunty Iron Age warriors. The beautiful blue women's clothing found in a grave on Lunde Heath in western Jutland. The Tolland man with his rope and his cap. He was sacrificed to the gods in the bog. A rich young Viking woman with large ornaments. A happy family in the Viking age. And a medieval wanderer. In Land of Legends in Lejre, we try to put series of small experiments into a larger picture. Many apparently small and unimportant questions about very specific prehistoric phenomena are a necessary part of the scientific cognitive process.
These have very little wood left on them. They've come off the stems really cleanly.
It's nice.
So I'm back again at Lejre, doing the final part of the process. This time we're trying to make things and take it all the way through to producing small samples of artifacts that might have been those that were available in prehistory. We're making, first of all, the nettle into fine fibre.
What might seem at first glance to be elementary and very down to earth can, in the twinkle of an eye, turn out to be the key to spectacular cognitive revelations. Humankind in the past and the present are connected through our common curiosity and creativity. By investigating the past, we become a little wiser about ourselves and the world about us.